Hi. So now I'm going to explain the Claisen arrangement. So in this chemical trapping, one is the Claisen arrangement. So in Claisen arrangement, mainly allyl phenyl ethers in the presence of heating, it converts to allyl substituted phenols. So here mainly here allyl phenyl ethers in the presence of heating. So here phenyl substituted allyl substituted phenols. Allyl substituted phenols. Phenols formation. This is a Claisen element. It is one of the chemical trapping reaction. So first of all, we are taking the one of the substrate molecule, that is a allyl phenyl ether. Okay. So this is a phenyl. So this is a allyl group. So here oxygen. COC bond is the ether. So this is a allyl phenyl ether. This allyl phenyl ether, upon heating, what happened? The group is migration to here. So the group is migration to here. So that is what happened here. This is a conversion of the here phenol. Here which is the substitution? Substitution is the allyl group. Allyl substituted phenol. Now see the mechanism. So here, so it is in the presence of heating, it is involves a pericyclic reaction. So 3 comma 3 sigma tropic shift is takes place. So here 1, 2, 3. Here 1 dash, 2 dash, here 3 dash. So what happened? 1, 2, 3. You take the here 1, 2, 3, 1, 2, 3. So here what happened? Here 3 comma 3 sigma tropic shift. Nothing but sigma bond is migration. Yes, 1 1 position to 3 3 position. Here 3 3 position, new sigma bond formation. 3 comma 3 sigma tropic shift. Sigma tropic shift. Sigma tropic shift. So what happened? The bonding electrons is attacking to here. The bonding electron migration. The bonding electron moving. So 3 comma 3 sigma tropic shift up under heating condition. Then here before formation of product, it is a what happened? Formation of the transition state. In that transition state is a bond breaking and bond making is takes place. The bond is breaking. Here new bond is formation. Here old bond is a breaking. Yes, here new bond is a formation. Here new bond formation. Here old bond breaking. So this is which is the transition state is formation. So transition state. How much member? 1, 2, 3, 1, 2, 3. 6 member cyclic transition state. Cyclic TST formation. So this cyclic TST, then it converts to the this one. So here double bond go, double bond, double bond. Here no CC bond. So then after this is a unstable because this ring is loss of aromaticity. Yes, this is unstable. This interior formation it is unstable because due to loss of aromaticity. So it wants aromaticity. It can be what happened here. What happened here? Keto inert atomization takes place. This proton is there here. Yes, here sp3 carbon. The bonding electron shifting to here, and the bonding electrons is shifting to oxygen. Oxygen gets negative charge. This taken by the H plus. Then it converts to double bond, here OH, here Li group attached to this one. So this is a 3, 3. Here new position sigma bond formation. Here which is the sigma bond is breaking? 1, 1 position is converts to sigma bond 3, 3 position. This is a S which is there, here Claisen rearrangement. So which shifting is takes place? Yes, 3 comma 3 sigma tropic shift in the allyl phenyl ether. Yes, allyl phenyl ethers. So this is a one of the simple Claisen rearrangement. But we are taking the mixture of the starting materials. So in this mixture of starting materials is taking two is allyl phenyl ethers, two different allyl phenyl ethers is taking. In the product is a yes, here intramolecular Claisen rearrangement takes place or intermolecular Claisen rearrangement takes place. So this is the one of the trapping of the intermediate. So here intermediate trapping, it is what happen here cross products is formation or maybe yes say self products is formation. Self product means intramolecular rearrangement. Cross products means intermolecular rearrangement. Please take this one. So similarly, I'm taking the one more example. We are taking the two different starting material. So it may be here only here no self products is formation or cross products is formation. But before example, cross products as well as self products is formation in the this element. But in the case of the Claisen element, only self products formation instead of the cross products formation. So now taking the mixture of the allyl phenyl ethers. So here which is there? Here methyl group is present. Okay. So now we are taking the here which group is there? Phenyl group is present. Yes, phenyl group is present. And here which is there? Methyl group is there. Here which is there? Deuterium is there. So these two are mixture can be subjected to heating. Heating is takes place. So both are undergoes the 3, 3 sigma tropic shift. Both are undergoes 3, 3 sigma tropic shift. So then resulting in the formation of the product is that. So this is a migration to here is bond is formation, here breaking is takes place. Here bond is formation takes place. So first one is what happened? Here CH3 is there. Here deuterium is present. Here OH. Plus here which is the present? Here phenyl group is present. Here OH. Here methyl group is substrate and here which is the allyl group. So what happened? Self products is formation. Products. Self products is formation and no cross products is formation. No cross products. Cross products. So therefore, this reaction tells that therefore, in this case, which type of reaction takes place? Intramolecular rearrangement is takes place. Molecular rearrangement. Intramolecular rearrangement. Nothing but the molecular rearrangement or here what happened? Migration of the group from one position to another position within the molecule, within the same molecule. That is a intramolecular rearrangement. So this is a Claisen rearrangement is mainly mechanism. This tells that intramolecular mechanism with the within the molecule rearrangement is takes place. Please take this screenshot. So no cross products is formation. No cross products means this group is going to here, this group is going to here. That is not possible because here cross products are intermolecular reactions mainly takes place in the reaction proceeding through the intermediate. If in a chemical reaction intermediate is formation, in that case here intra and intermolecular rearrangement is takes place. If intermediate is not formation, only the reaction is proceeding to transition state. That in that reaction only self-products formation, nothing but the intramolecular rearrangement takes place. So we have noted one important conclusion for about the chemical trapping. Yes, chemical trapping method. Chemical trapping. So in chemical trapping, one important thing is there. So here we have studied the three reactions. One is a benzene mechanism intermediate. Second one is a chemical trapping method. Is a base rearrangement. Third one is a Claisen rearrangement. So we have studied the Claisen rearrangement and base rearrangement. So base rearrangement is mainly takes place intramolecular as well as a intermolecular rearrangement is takes place. But in the case of the Claisen rearrangement, only intramolecular rearrangement takes place, but not intermolecular rearrangement. So here chemical trapping main methods. Here first method, one method is a price rearrangement. Price rearrangement. So price rearrangement mainly what happen? Here self products plus cross products is formed. Cross products formed. Okay, means this indicates that self products means intramolecular rearrangement. Intramolecular rearrangement. RE means rearrangement. So here cross products indicate intermolecular rearrangement. So because in this case is rearrangement here two products is formation because due to due to due to due to in this reaction due to because in this reaction because this reaction proceeds because this reaction proceeds through intermediate intermediate. Okay, next one, second one is a so intermediate cross products is formation. Whenever cross products is formation, chemical trapping is takes place. Chemical trapping is takes place. Chemical trapping is possible. Here self products means intramolecular rearrangement. No chemical trapping is takes place. Next, another here in chemical trapping. Second one is which is there? Here Claisen rearrangement. Claisen rearrangement. Claisen rearrangement. So in this rearrangement, only which is formation? Self products is formation. Self products. No cross products. No cross products. So cross products here, no form, not common. So self products is formation. Yes. So this self products is mainly due to intramolecular rearrangement. Intramolecular rearrangement. So here because no cross products. Yes, no cross products formation in this reaction is due to is due to due is due to is due to it proceeds transition state due to this reaction proceeds due to this reaction proceeds proceeds via transition state. Via transition state. Transition state. So transition state, no intermediate, only one reference. We are taking two reactions for the chemical trapping. One is a phase rearrangement and Claisen rearrangement. Phase rearrangement is a here chemical trapping is mainly takes place. Chemical trapping means cross products formation. But in the case of the Claisen arrangement is there, here no cross products is formation, only self products is formation due to this mechanism proceeding to via transition state. But this reaction proceeding through via yes intermediate. So in a chemical reaction, it proceeding through the intermediate via intermediate cross products as well as a self products is formation. Cross products means intermolecular rearrangement, self products means intramolecular rearrangement. But in a chemical reaction, only self products is formation, no cross products is formation due to it proceeding through the via transition state. In the transition state is proceeding, therefore here only self products is formation. So in Claisen arrangement, no chemical trapping is takes place. But in the case of phase arrangement, chemical trapping is takes place. So chemical trapping means here intermediate can be identification easily. Intermediate is involvement in the chemical reaction. So therefore we can here identification of the intermediate is possible in the cross products formation reaction, that is a phase arrangement. But in the case of Claisen arrangement, there is no intermediate formation. It is proceeding to transition state. Therefore, here trapping of the intermediate is difficult. So, as final conclusion, price rearrangement, chemical trapping is takes place. Chemical trapping. Here, Claisen rearrangement, no chemical trapping. So, here, price rearrangement, intermediate, by using this one, is study of reaction intermediate. Study of reaction intermediate is possible. Here by using the Claisen rearrangement, not possible. Please take this screenshot. And yes, another one more concept is a study of the intermediates, reaction intermediate, by using the physical technique like as a spectroscopy. In that spectroscopy, mainly we are using the IR and NMR spectroscopy. IR and NMR spectroscopy in a chemical reaction by using the IR and NMR spectroscopy in a chemical reaction, the intermediate is formation or not. The reaction in a chemical reaction, intermediate is formed or not. So that can be studied by using the two techniques. Mainly, these are the one is a H1 NMR, second one is a here IR spectral data. Okay. So see here, use of IR and NMR in the investigation of IR and NMR, use of IR and NMR in the investigation investigation of reaction mechanism of reaction mechanism. Use of IR and MR in the investigation of reaction mechanism. So this is a very important concept. Very important concept. So by using the IR and MR, yeah, this is an advanced technique. This is mainly spectral technique. It is an advanced one. Compared to chemical one, here physical method. Physical method is easy because after investigation of the intermediate or after study the internal reaction mechanism, by using this technique, the sample is recovered back. But chemical technique not possible recover back. So therefore, compared to chemical method, here physical method is a more advantage. So advanced method, this is a physical method. Physical method. So first of all, IR spectral study. So study of the IR spectroscopy. IR spectral. So first of all, taking the one of the reaction. This is a carbonyl compound, C double bond. This carbonyl compound is in reaction with the hydroxylamine hydrochloride. So in the presence of the acidic medium, so then which is formation? Oxide is formation. So this is what happened? Ketone carbonyl group. Aldehyde or ketone carbonyl. So this is a hydroxyl amine. Hydroxyl amine. In presence of acid. So which is formation? Oxide is formation. Oxide. So in this chemical reaction, a carbonyl functional group reaction with the hydroxylamine hydrochloride, then resulting product is which is formation here oxide formation. So here C double bond N is a no functional group is obtained, and here which functional group is disappear? C double bond O is disappear. Generally, in this is a chemical reaction. In this reaction, starting material yes IR spectroscopy, carbonyl stretching frequency is a 1700. So here mu CO is stretching frequency 1700 to is 1725 centimeter inverse or approximately 1717 centimeter inverse. So this region is stretching frequency is given by this starting material. After which is the completion, a combination of the oxide and combination of the water as a byproduct. So here in this case, here the C double bond N majorly here not appear in the region. So in this frequency, so with the 2 minutes past disappearance of the carbonyl functional group by reaction with the yes hydroxylamine hydrochloride, and here what happened? Slowly appearance of the C double bond N. Slowly appearance of the C double bond N. Here the frequency takes place in the IR spectrum. So this is around 2000 S200 and above temperature. Why this oxide also unstable? So what happened? This is a OH and this is a R group is lost. Then it can be converted into cyanide. Cyanides mainly 2175 to 2200 centimeter inverse. Nothing but what happened in this case? Here reaction the here oxide here Carbonyl group is fastly within the 1 minute. Here what happens? The frequencies disappears, and here around S2200 near to 2200 centimeter inverse, a new band is appeared in the NIR spectroscopy. So the C double bond N is a fast appearance in the, and C double bond O is a slow disappearance, fast to disappear C double bond O, and S slow appearance of the C double bond N. So therefore this gives the information about the reaction. It is takes place not a single step process. The reaction takes place not a single step process. From IR spectra, the mechanism is expected as. So what happened here? This is a here appear. The reaction is managed in the a vessel and study the intermediate. So this is a what happened here 1720 or 1700 to 1725 centimeter inverse. No peak is appeared, but it is appears around 22, nearly 2200 centimeter inverse. So what happened? The reaction is caused. So here carbonyl group is a fast disappear, fast disappear, and here C double bond is a slow formation, slow appearance. Slow appearance. So therefore, this data evidence is says that this mechanism, yes, not a takes place in the single step. It can be taking the multi-step reaction. Single multi-step means more than one step. So more than one step. That can be here based on this one IR spectra. We can propose a mechanism. See this one. Here C double bond O carbonyl group. This is a delta plus, a delta minus, a electrophilic center, and treated with the hydroxylamine hydrochloride. So this is a which is there. It is act as a nucleophile attacking this electrophilic center. The bonding electrons is taken to here. So this is the nucleophilic addition. Nucleophilic addition. Then RC, here double bond converts to single bond. Here oxygen gets completely charged. Here delta minus means partial charge. Partial charge converts to complete charge. And N with two hydrogens. Here OH. Here loss of lone pair of electrons gets positive charge. Then what happened? This is taking the bond pair of electron. The which is there, H plus is taken by the hydrogen loss H plus that can be taken O minus. So then this is what happened RCOH, here R, here NH, here OH is formation. So this is a formation. This is a highly unstable intermediate, because this single carbon having the how many high electronegative atoms is present? 1, 2. Yes, nitrogen is a more electronegative compared to carbon. Oxygen also more electronegative compared to carbon. So here geminal high electronegative groups is present on the carbon. Therefore, it is unstable. So what happened? This bond pair of electrons is taken by this OH. Then the bond pair of electrons is shifting. So simultaneously, H plus OH minus loss of the water molecule is takes place. Loss of the water molecule takes place. Then, which is formation? Here, C double bond N OH, here RH formation. This is a which is an oxide. This oxide is also unstable. So this oxide is also unstable. Then further it can be decomposes and it converts to is what happened here. For example, if RH is there, here RH called H is there, H and OH lost, then what happened? Cyanide is formation. Yes, if R is called H, if R is equal to one of the R is equal to H, what happened? Water molecule is lost. So this is mainly appear around 2200 centimeters in the IR spectroscopy. So this data evidence that this reaction is not proceeding a single step, it takes place a multi-step. So from IR spectral data. So IR spectral data is says that the starting material here carbonyl group appears the IR stretching frequency C double bond or stretching frequency at around 1700 to 1725 centimeter inverse, approximately this region. But this is taking in the reaction vessel and add the hydroxylamine and hydrochloride in the presence of acidic medium. So that is a HCl or H2SO4 adding the catalytic amount. So what happened in this reaction? Condensation takes place. Yes, the fastly C double bond or stretching frequencies disappear in the reaction mixture and slowly appearance of the S here another stretching frequency around 2020 and 2200 centimeter. So that indicates that it is a fast disappearance, it is a slow appearance. Therefore, it is the reaction not a proceeding a single step. It can be proceeding a multi-step. So by using the IR spectra, we can easily identification of the intermediate. So this is oxime is an intermediate, but it is not stable. Oxime further decomposition, it can be formation of the cyanide. Second one is a H1NMR spectral data. H1NMR spectral data. So H1NMR studies states that if the reaction is proceeding in the how many steps. So it yeah, for example, yeah, mainly addition of the bromine to olefins. Already we are studying in the starting. Yes, addition of the bromine to the unsaturation. Then formation of the trans 1 comma 2 dibromo alkane is formation hydrocarbon. But it is proceeding in the which mechanism is correct? Proceeding via is carbocation intermediate or maybe cyclic bromonium ion intermediate. So which is the correct that it proceeding in the two pathways? Which pathway is correct that can be revealed from the H1NMR spectra. So real chemical reaction proceeding only one pathway, not a two pathways. The one pathway that can be evidenced by the H1NMR spectral data. For example, see here addition of addition of Br2 Br2 to unsaturation bromine to unsaturation. So bromine to unsaturation. See here, this is a unsaturated compound. Here addition to Br2 bromine by using the SbF5 S titanium pentachloride SbF5 already discussed S in the liquid sulfur dioxide at minus 60 degrees centigrade. At minus 60 degrees centigrade. So here mainly which is formation? Intermediate is formation. Intermediate. This intermediate further which is formation? Here formation of the trans 1 comma 2 dibromo hydrocarbon. Trans 1 to dibromo hydrocarbon. So here intermediates is mainly how many formation? Two intermediates. Two intermediates is formation. But really, by here two intermediates is possible, but really one intermediate formation that can be evidenced by using the H1NMR study. So one of the intermediate is a already discussed this one. So one is a bromine cation. So carbocation intermediate. Carbocation intermediate. Another one is a cyclic bromonium ion. Cyclic bromonium cyclic bromonium. These two are the intermediates. So these two are the intermediates possible according to. But here what happened in H1 NMR? In H1 NMR, it gives the two signal. For example, if hydrogen is there, if hydrogen is present, so these protons gives around one signal is a S 18 delta ppm, 18 delta ppm, and the bromine attached protons appeared at the S 2.8 delta ppm. 2.4 to 2.8. So how many signals is present? This protons gives this protons. So two signals. Two signals. Theoretically. But in this case, here protons is there. So these protons combined gives only one signal. Only one signal. One signal. One signal. At 5.8 delta pp. So only one signal here gives as a two signals in the H1 NMR. Generally this intermediate. But real H1 NMR, so the intermediate is gives as a only one signal. Therefore, the reaction proceeding which mechanism? Yes, cyclic bromonium ion mechanism. This is a via cyclic bromonium ion intermediate, but not the carbocation intermediate. So by using the H1 NMR spectrum, it is a two intermediates is possible. One intermediate is gives two signals in H1 NMR, and this intermediate is gives one signal in the H1 NMR. But real NMR, real H1 NMR studies tells that the reaction proceeding via intermediate, the intermediate gives as a only one signal corresponding to protons. So that indicates that the so which mechanism is correct? The mechanism is a cyclic bromonium ion mechanism, but not the carbocation mechanism. So therefore, this by using the H1 spectral data, we can study the S reaction mechanism. We can study the reaction mechanism. Please take this one already discussed in the starting. Addition of Br2 to unsaturation means alkenes if proceeding through two intermediate pathways. That is first one is a carbocation intermediate. Carbocation intermediate gives how many signals? Two signals. Two signals in H1 NMR. Second one mechanism is proceeding through cyclic bromonium ion intermediate. So it is gives as how many signals? One signal. One signal in H1N1. Real H1N1 studies reveals that this reaction intermediate give one signal corresponding to all protons all protons. Therefore, the H1NMR supports the cyclic bromonium ion intermediate, but not supports the carbocation intermediate. Therefore, H1NMR spectral data supports cyclic bromonium ion intermediate. Cyclic bromonium ion intermediate. Therefore, this reaction proceeds only cyclic bromonium ion intermediate, but not carbocation intermediate. But not carbocation intermediate. So, thank you to all. This is about reaction mechanism. It's completed. Thank you.